Okay, our next thing that we looked at with probability was all about random variables. So a random variable is a variable whose numeric value is based on the outcome of a random event. There were two main types of random variables we looked at. We looked at discrete and continuous. So we'll start with focusing on discrete. Okay, if you have a discrete random variable, it means that you could make a list of the outcomes and each of their probabilities. So if you're thinking about like a carnival game, if you land on blue, you might win $4, red, you might win $2, and yellow, you might win $1. I could make a list of all of those different outcomes, the colors we just talked about, and then the probabilities based on whatever the board looks like. Okay, when we're finding the expected value or the average or the mean of this discrete random variable, what we said to do was take each possible value, so that was our x, and multiply by the probability of that event occurring. So, quick example, let's say I'm doing that carnival game we talked about. We'll have half of it be red, and then a fourth yellow, and a fourth blue. Red, you're going to win 4 tickets. Yellow, you win 2. Blue, you win 1. So if we were finding the expected value here, I'm just going to jump up top. I would take the probability, so if I'm doing red, that's 50%, so I would do 0.5 times the tickets, so I'm going to win 4 tickets. Plus my next outcome, I could do, let's say yellow, fourth there, so I'm going to do 0.25 times the tickets I'm winning, which is 2. Plus for blue, I have 0.25, only winning 1 ticket there. And then I would use my calculator to calculate this expected value. Okay, so my expected value is 2.75. That means on average, if I were to sit here and play this game over and over and over again, I'm expected to win an average of 2.75 tickets. Now, sometimes that can't happen each time, like there's no spot on this spinner that says I can win 2 3/4 of a ticket, but on average, that's my expected winning. Okay, next we talked about standard deviation. Finding the actual standard deviation is tricky. We have to square root the variance. To find variance, what we're going to do is a bunch of adding again, just like we did with our expected value. We're going to take your outcome, subtract the mean, or in this case, expected value, square it, because some are going to be positive and some are going to be negative, and then multiply it by the probability. So, if I'm finding the standard deviation for this spinner, I would start with taking an outcome, subtracting the average. So if I'm looking at red, my outcome was 4. The average we just found was 2.75. I square it, and I multiply by the chances of that event. So the chance of getting red was 0.5. I'm going to add and do the same thing for the next event. So 2 tickets for yellow minus the 2.75. Squaring it times the probability, so 0.25. Last event, have 1 minus the 2.75, and I'm squaring it times the probability. Okay, I'm going to go ahead and type that all into my calculator. Okay, so this gives me a, sorry, I wrote standard deviation. Technically right now I'm finding the variance. So I got a variance of 1.69 9-ish. Finding the standard deviation then, I would just square root this. So square rooting my answer gives me 1.299, so I would say 1.3. Okay, next we talked about different operations with mean and standard deviation. So the first one is looking at adding a constant. So if I said with this little spinner game, I'm actually just going to add on 1 ticket to each spinner to try and, attract more people to play the game. So instead of 4 tickets for red, you're going to win 5. Instead of 2 for yellow, you're going to win 3. Blue is going to be 2. We're just adding 1 on. That's adding a constant. If you're adding a constant on, your expected value is also going to add that constant. Same for subtraction. Okay, what's tricky though is that variance is not impacted by adding or subtracting of this constant, so your variance just stays the same. If everything is being added by 1, it doesn't change how spread out things are. So if I started with my data being this spread, adding 1 doesn't change the spread. Okay, with multiplication, so if I say, actually I'm going to just multiply all the prizes by 2, well, that expected value will also multiply by 2. Since variance is a measure of squared units, your variance will be multiplied by that constant squared. So instead of just taking my variance and multiplying by 2, I have to multiply it by 2 squared. Sometimes we'll look at multiple variables, so maybe you're playing my carnival game and Miss Mollahan's carnival game. You want to find your total expected winnings, so you'd be adding those 2 random variables. Maybe you want to find the difference, so you're subtracting. Expected value is pretty straightforward. You just add or subtract whatever the expected values are for those 2 random variables. Variance is always a little bit trickier. Since variance is measuring how spread out things are, adding on or subtracting this second random variable is always going to increase your spread, so variances always add. Variances are always a little bit weird, so I would definitely take note of these variances. Expected value is pretty much what you expect to happen. Variance is a little strange. Okay, let's go ahead and do an example here. So it says for the random variable x, the mean is 10 with standard deviation of 2. Find the mean and standard deviation of the following. So part A says 2 times x. So I'm multiplying by 2, which is the second rule that we talked about here. So to find my expected value of 2x, I'm just going to split this up into 2 times the expected value. Well, the old expected value, or the mean, was 10, so 2 times 10 gives me 20. Okay, finding the variance of 2x. Remember that multiplication needs to be squared, so 2 squared times the variance. Now, right now, they just gave me standard deviation. So to change this into variance, I would have to square it. So 2 squared is 4. So when I'm multiplying by that old variance, I now have 4 times that variance of 4, giving me 16. To change it into standard deviation, all I need to do is square root it. So square root of 16 is 4. Next one is x plus 3, so I'm finding the expected value of x plus 3. So I'm going to split it up in the expected value of x plus 3. That old expected value is 10, and 10 plus 3 gives me 13. Okay, I'm finding the variance of x plus 3. Remember that variance is not impacted by adding or subtracting of a constant. So this should just be my old variance, which was 4. Again, to change that into standard deviation, I square root it, which gives me 2. So watch that there, make sure that variance is not adding on 3. Okay, and then this last one, I have x minus x, so I'm finding the expected value, x minus x. I'm going to split it up, expected value of x minus expected value of x. My old expected value is 10, so 10 minus 10 gives me 0. Last part here, I'm finding the variance of x minus x. This part's a little tricky. Even when I'm subtracting, my variances always add. So I'm really going to take the variance of x plus the variance of x. My old variance was 4, so I have 4 plus 4, which is 8. To change it into standard deviation, I'm going to square root it. Square root of 8, oops, gives me 2.83. Okay, after discrete random variables, we looked at continuous. Okay, with continuous random variables, you no longer have a list of these outcomes and each of their probabilities. Instead, you're going to have variables that can take on any value. For example, you might have weight, you might have height, but it's impossible to make a list here of all of the weights, all of the heights that have ever existed. I mean, we can be very, very specific. There's no way we can make a list. What's nice about continuous random variables is the same properties as we looked at here apply to continuous. So these same operations apply to continuous. Once you have that mean and standard deviation, you would just set up a normal model. So you would have your little model here with your new expected value and your standard deviation. And then you could find your z-score and use normal CDF to find what probability they're asking you for.